to guide you today through this morning. Today we are getting 6 presentations. We have 4 online and 2 which
recording in progress
done here in the room. This will go from now until 11. Then we will get a field visit to Al Hoceima MPA from 11 to 1 p.m. Then starting from 3 p.m. to 4:30, we're getting a poster session at Al Hoceima MPA Observatory. We have many planned posters that will be shown. So today we have a diverse range of presentations that will be made. They will shed light on innovative tools and approaches driving maritime innovation and knowledge management. A quick reminder for speakers, you'll have 15 minutes each for your presentation. Following each presentation, we will have 5 minutes for questions and answers. So please try to stick with your time. Today's first presentation will be made by Mr. Valentine Venus from Ramani, who will start by introducing us to the SEMflow online tool. So, Mr. Valentine. Valentine, the floor is yours.
Good morning. It's a pleasure to be invited here. Thank you very much to the organizers for the excellent organization of this event, and also to the audio and video team. It's excellent. So I'd like to talk today about a tool that we started developing some 4 years back, organizing international competition events. That's our bread and butter, also in the maritime domain. And the screens are coming, I guess. Yeah, there we are. And so since 2014, we've been doing these international competition events already with some 650 participants globally, both for the European Space Agency, NASA, European Commission in the Cassini hackathons, but also commercial companies such as SAP, T-Mobile, Deutsche Telekom, and also recently Haubraum from Poland. So I'd like to show you the apps we developed as an example that this thing also works in Africa. We've compiled a video just to give you an introduction to why we developed SEMflow. So please play the video. All right, so the video will come in the second presentation, which will also be on the topic of building citizen science application using the same tooling. So I'll be offering you that one later. So here's the example of the IoT Space Challenge. We ran together with ESA and Deutsche Telekom the new Copernicus data ecosystem. So we invited over 40 companies to present their ambitions to combine IoT data, also marine buoy, small drifters, with Earth observation data, and to see how we could leverage the mutual benefits of these data sources, heterogeneous, often different of type and formats, as you can understand. and then try to see where the added value is and how we could combine this data to overcome each other's weaknesses. So in the next, you see the announcement we ran last year with me pressing a button. No, wrong one. So here you see the different domains and thematic challenges we lined up. And so out of 40, we coached 6 teams, including a French company, as I mentioned, focusing on building new low-cost drifters to measure currents and temperature in global oceans. What you can imagine that if you run an international competition event with people with very diverse backgrounds, experts, technical IoT, but also Earth observation and maritime CMEMS and other data sources, that there's a lot of confusion initially. People use their own jargon, their own vocabulary. So here we introduced the idea of cross-domain knowledge management. So here's, as you know, a keyword also that we have been using for many years now, knowledge graphs. Every time you search on Google search, knowledge is harvested from the internet and turned into what we call a knowledge graph. And a knowledge graph is basically an artificially generated description of knowledge so that your answers are automatically provided when you raise a question. Now, data can be accessed and used only if we do some semantic uplifting. So that's also a key keyword today. So these web semantic technologies allow people to talk the same language in combining heterogeneous data sources. So according to Gartner, ontologies are also key in this process, a key building block. I can't even see my own slides, so I have to open it here as well. Yeah, it's fine, but I just can't read my own slides from here, so I don't know how the others do it, but I think I need my laptop. Is that okay? Where? Oh, here. Sure. Ontologies are structural frameworks for organizing information, are used as knowledge representations. So ontology management supports and expands data modeling methodologies, particularly to exploit the business value locked up in information silos. So maybe a question to the audience. Have you discovered when, for example, starting and initiating a new project, that oftentimes we misunderstand each other just because we use a vocabulary or jargon that is specific to your particular domain, and other people sort of struggle trying to comprehend the semantic meaning of those terms? Well, if it's something that calls perhaps bad memories to mind, this is certainly the case for short-lived international competition events. Students don't, and young people don't have sort of the human neural network developed, not having spent years in the particular domain. So you have to help them visualizing these concepts and knowledge. So here you see an example of the same. Basically, it's a mind mapper on steroids. You've all heard of mind mapper software, where you have a visual canvas on which you can organize concepts and knowledge. So to easily organize also digital assets such as data on this visual canvas, SimFlow uses large language modeling and NLP to build a corpus of thematic knowledge in these different domains such as IoT, space, marine conservation management, for example. And this can be then, of course, used also as an educational digital textbook. So here you see in the screen up there concepts related to artificial intelligence, visually organized on a canvas, where the semantic relationships define the connections. And then in the text below, you see a PDF or a Word document that also now has the same keywords or classes being highlighted in green or red to show the alignment between the concepts and their relation and other types of media, such as a Word document or a PowerPoint. This enhances the speed with which we are able to understand and communicate. Similarly, Elsevier medical publications, you cannot publish an article on Elsevier unless it has gone through the loops of actually making sure you're using the right DNA or other medical terms used in this domain. How do you work with ontologies? Well, a few basic concepts first. So here we see how to build this common vocabulary talking the same language. We have a top-level ontology, domain-independent, aka mid-level ontologies, and I will give a few examples of those. And then down at the bottom, we arrive at subdomain ontologies and even application-specific ontologies. So an example of a domain-independent general-purpose ontology is, for example, the DUF, dataset usage vocabulary, or SOSA, sensor observation sample actuator, or data quality ontology. And this is also important to realize, oops, nice, well done. This is also important to realize that you can expand this. So here you see examples of application-specific ontologies in subdomains. Here in the ballast water risk management and port risk assessment pilot in Iliad, which we are also part of together with Sparak and Port of Valencia and Hussein here in Morocco, is that we also need to understand what are the concepts in port risk management. So here we've got a cooperative risk management and seaport ontology and infra risk ontology. So here you see some concepts that we can then import from existing ontologies or create our own, and the process of creating our own will be shown here. So here on the top left part we have a search tab where we can search for existing concepts. Classes and class ontologies are then either added or removed from your mind mapping canvas. And then you can start adding your own or modifying the relationships between these classes. This is all visually and very interactive and intuitive, we hope. So you can then click on the sort class and drag the connection tool to target a semantic relationship with something else. We will illustrate this in a minute based on a practical example. I will just go through these slides. Changing a class name, saving the changes and whatnot. So this is the process of working in a cycle of 3 steps. There's a wizard that we built for this that guides you through these steps. And here you see now the feedback loop between the concepts on the canvas and the repetition and use of those in different media types. So this might be a Horizon Europe deliverable that you jointly write with other co-authors, and you would love to make sure that we're all on the same page. But also, once we are using similar classes, we can also develop software based on this, such as Here is an example of an invasive species smartphone application called Lemon. And Lemon sort of presents data from the WORMS World Registry of Marine Species to help understand the threats of invasive species. And I mentioned you can also then, of course, create a data processing pipeline that analyzes and processes Copernicus CMEMS data that are relevant for this habitat modeling as we've seen in the previous presentations. Here's an example of some of the processing that you can then call on. So say, habitat modeling requires to understand the habitat preferences of a species, which came from the previous knowledge graph. So that's the species name, the taxa, what kind of salinity and temperature conditions does the species prefer. And then you say, okay, then currently I need a monthly average that explains key steps in the life cycle of this species. For example, propagation, when the species wants to propagate. So crabs lay eggs, as we all know. In which month is this occurring? And what are the ocean temperatures at this particular month to prevent it from spreading? And if it's too favorable for this invasive species, the risk is very high. So here you see that knowledge graph, but then in a workflow for data processing, and then the outcome is the previous with the anomaly of chlorophyll A in West Mediterranean waters. Right, so I will go to the conclusion. So the process of building all of this is guided through a wizard. And so you can then also export your data to, say, other formats. Here's downloading data in various forms, NetCDF, whatnot. But you can also directly consume this data in your smartphone application, and I will talk about that at the end of this morning, or export this workflow to CWL, Common Workflow Language, so that you can run it on, say, the Edito infrastructure. So if you want to learn more, get in touch with our lead developer, and if there are any questions, I'm happy to take them, or if you want to learn more, we also run courses at the university. For example, how to be more expressive in public media and include data visuals underpinning your online or paper-based media publications.
Well, thank you very much. That was an impressive presentation on the same flow. It's impressive how it has been developed, thinked, etc. So, any question from the room? Online questions? Okay, so I will ask mine, if you don't mind.
Yeah, please.
Well, so considering the complexity of the interdisciplinary collaboration, how do you foresee the same flow? Okay. Has it took into account the UX, the user experience part? Is it easy to use? And is it addressing the specific challenges faced by non-IT experts and ensuring effective communication in the development of digital information tooling, especially for the marine domain and marine conservation domain?
Yeah, excellent questions. Thank you very much. Well, the proof of the pudding is in the eating, they say. So in the ILIAD project, we hope to engage several pilots that are cross-disciplinary by nature, to see indeed, one, if people feel at ease and comfortable now that they are helped talking the same language. What is the, say, decrease in the amount of email communications people have to send each other to get their points across in a discussion? So we also have what is called an author, editor, publisher tracking system, just like track changes in Word documents. So you can actually see that you logged in and you added a class or you had a comment about someone else's relationship between classes saying this is not proper. So for example, in the ballast water management pilot, we have this example of the port risk ontology. Well, there is an outgoing relationship, water condition and weather condition. Each port has its own weather and water conditions. So we'd like to populate this orphan water condition class with chlorophyll A, with salinity, oxygen at the base, to make it easier for the IT person to build the workflow. Yeah, if you give me the floor, I will take it.
Thank you very much, Valentin, for your presentation. Thank you very much. As we don't have any question from the meeting room, no, from the online, we will go through the next presentation, which will be done online by Ms. Marina Markovic from the PAPRAC. The PAPRAC is one of the... Okay, I'm sorry. Well, I was saying that we will go through the next presentation made by Marina. Good morning, Marina.
Good morning.
From PAPRAC, which is one of the 5 map components. They are dealing mainly with the ICZM, the MSP, etc. She will talk about the MSP workspace for the Mediterranean. So, without losing time, Marina, the floor is yours. Thank you.
Thank you. Thank you very much, first of all, for inviting PAPRAC to be part of this really important event. Of course, I'm really, really sorry that we couldn't, and me personally, be with you. But I hope at least this is a little bit of contribution. I don't like this hybrid online participation. I would prefer to be with you. But yes, we are still grateful for the technology to enable us at least participation like this. So I will share my screen, just if you can give me some time. Sorry, just 1 second.
To go on full screen mode.
Yes, yes. Is it better? You see it now?
Yeah, it's perfect. Thank you.
Thank you very much. So today, a little bit different from the previous presentation. I will really shortly present to you one sort of a portal that we have developed to support Mediterranean countries in working on marine spatial planning. So this is something we call Mediterranean MSP Workspace. It is practically a website where you can find different information about marine spatial planning. It's not extremely comprehensive. It doesn't address all the possible details about MSP, but it is very much focused on supporting actually the planners in the Mediterranean and also policymakers that are in the process of developing their marine spatial plans. And the key information we are giving in this portal are those related to the governance, climate action, ecosystem approach, and land-sea interactions. Of course, everything in the context of marine spatial planning. So these are these core themes. So once you log into this, when you enter this website, under the core themes, these are the main key elements that you can find. So what kind of information we offer? In terms of governance, there are some basic information about really the legal system in the Mediterranean relevant for marine spatial planning, but also some of the very specific steps you need to take into consideration in order to have your plan being, how to say, involve stakeholders, be open to do the appropriate steps to agree vision, and also to do the objectives and follow-up steps to implement the vision. Ecosystem approach is something in marine spatial planning that is really important, and in the framework of UNEP MAP, this is something we are highlighting very much. Of course, blue economy is the main, let's say, guiding force for marine spatial planning. But I think it's extremely important that these plans are done in a way to respect the ecosystem and really to be done as part of the ecosystem approach. It's, of course, easy to say, okay, let's do it in ecosystem-friendly way, but what does this mean? This is where we are trying to support policymakers and planners to provide a specific steps that need to be undertaken in order to make your plans in line with the ecosystem approach. Similar is to climate change. So climate-proof MSPs is something that is really now the topic, and all the countries are trying to have their MSPs very much climate-proof. In order to somehow address this need, we are providing specific recommendations for each sector relevant for marine spatial plan on how can they make their activities in such a way to mitigate climate change, but also to adapt to the climate change. And finally is the land-sea interactions. So the marine spatial planning we are promoting and actually developing is the one that is in line with the integrated coastal zone management. So in that sense, coastal zones, it's not something that is just on the land. This is the usual perception that coastal zone is just land, but coastal zone actually includes both land and the sea. So any marine spatial plan that should be developed needs to take into consideration all the activities and natural processes that are coming or that are happening on the land part, but also to understand and how these affect the marine activities and marine environment, but also at the same time to understand how any marine activities are linked or have any kind of impact on the land. So this interaction is something that needs to be incorporated in MSP. As a, let's say, central part of this platform is actually are the MSP steps, specific stages that guide policymakers how to design a plan, providing the specific activities that need to be done as part of every stage, and also taking into consideration all these 4 elements that I was talking before. But maybe the most important part of this platform are actually these planning tools that you can find. So for each of the 4 topics, we are offering a specific tool or the checklist that you can use to see how well you are progressing in addressing any of these 4 components. So here you can see it. So this is available online. This is something that for each of the stages of MSP, you have a specific questions that guide you on how to address specific topics, and you can online, let's say, fill it in to see how much you completed. You can add your specific comments, address priorities, etc. This is something that can also be quite useful for the stakeholder workshops or stakeholder involvements. And at the end of each stage, you get a sort of, let's say, review on how much you completed your particular stage and whether you are advised to move to the next one, or maybe you should stay a little bit longer in this specific MSP stage and try to address these additional things. So these questionnaires and these checklists, they exist online, as I just show you, but you can also download them and work offline in the form of Excel file, but also to help you have your MSP plan developed. So this is, let's say, initial version of this approach. So if you're interested, or if you are in any stage of MSP plan development, or you are planning to do it, we would very much appreciate if you can get in touch with us and maybe test how does this work. Do you find it useful? Do you have recommendations for improvement? So we would really appreciate that you get in touch with us and provide us your feedback for maybe improvement of the approach for the next stages. So thank you very much. I'm of course here if you have any kind of question. Thank you.
Thank you, Marina. Thank you very much for the presentation of this MSP workspace for the Mediterranean. Indeed, it seems to be a valuable tool that is intended especially for policymakers, decisioners, people who are preparing policies. Is there any question from the room, please? Online too? Come on, please, more active with us this morning. You're sleeping. Well.
Okay, I see one question online, yeah. I think. What are the main challenges that you are facing regarding the stakeholders? Stakeholder involvement is one of the most important, and but also, of course, one of really the most challenging aspects. So, and I can say, in the context of coastal zone management, I think there is a lot of interest from the stakeholders to get involved because, especially if we are dealing with land use part of the topic. However, once we move to the sea, I think people are still not so familiar with their particular role in marine spatial planning. So I think it is particularly important in the process of MSP to work even more to have stakeholders involved and really engaged from the start. But of course, engaging them from the start is critical, and we need to work always extra hard to be close to any kind of stakeholders and somehow to engage them as much as possible.
Thank you very much, Marina. Thank you all. We have a question from the room.
Yes. Hi, Marina. It is Anis from Sparak.
Hello.
Thank you for being with us. Just a question to be sure. I mean, this platform is both for countries who will be starting the MSP process, but also for countries that have already the MSP in place and want to assess the progress, right?
So this is maybe more for those that are in the process of developing. I think it would be much more useful in this part of the process, so when you are developing, because it gives you specific steps for each of the stages of MSP process. But of course, once you have your MSP developed, the story doesn't end here. So of course, it's always thinking in advance on your next stage. So it can be useful even in after you have your plan to do some, let's say, reverse check on how you did it, what you did it, and maybe what are your key gaps, especially in the context of climate change and the ecosystem approach, and maybe to help you for your next stage of MSP to see how you can improve it.
Thank you, Marina.
Thank you very much. Thank you, Anis. So I think it's time to go to the third presentations today. Joining us, Mrs. Annalisa Minelli from Inforac.
Morning to all.
Hi. Can we see Miss Annalisa on the screen?
Yeah, I hope so, at least.
We are getting you. So Annalisa is from Inforac, which is another Barcelona Convention component, an important one. They are charged of the collection and dissemination, preparation of data. So Annalisa will present with us the key for UNEP-MAP knowledge heritage, some kind of key map prototype. It is a key map prototype. Well, so Annalisa, you have the floor. Please.
Okay, so maybe the key for UNEP-MAP knowledge heritage as a title is a bit ambitious, but since we still have only a prototype, but yeah, this is what we aim to do. This platform, during this presentation, we will look at a bit of what is K-MAP. So it is called exactly K-MAP because it aims to be a sort of unique hub to all the UNEP-MAP knowledge heritage. Just a step behind, Inforac is the regional activity center charged for, which has as mission the information and communication. So we deal with data from all the Mediterranean, and we deal with communication. That means dissemination, basically. So in our program of work, this platform represents a sort of mix of the two missions, because we deal with data, so we will see a lot about data management during the presentation, and it deals with dissemination. We will have a part related to how we present, let's say, the knowledge heritage of UNEP-MAP to the wide public and inside the UNEP-MAP system itself. So we will go through some principles which are inherited directly from the adopted data policy of UNEP-MAP, evidently. We will see some general principles and the fair data management. We will see some preparatory activities and the implementation timeline of this prototype. And then we will have a look also to the future activities. We will have a little browse of the platform with having a look to the K-MAP products in general and the architecture. So we will see how it works. So how we can parse it and how it's done. So the pieces of the platform and the software also. So what is K-MAP? So K-MAP aims to become, so it's a name, evidently it's an objective, a unique access point to all UNEP-MAP knowledge heritage. Saying all UNEP-MAP knowledge heritage, it's a bit huge, as you might understand, because UNEP-MAP is made by all the contracting parties, so all the countries, then all the regional activity centers. So what we tried to do is to have a better idea of what there's inside all UNEP-MAP and trying to systematize all these pieces. And the other important point is that since K-MAP manages also documents, is not only an SDI. So we are speaking about geographical data for sure, but we are also speaking about documents. So libraries, basically. Then the actual prototype is composed by two elements, which are the data hub and the knowledge hub. Data hub manages geographical elements and is accessible through the maps button on the platform. And the knowledge hub manages documents and it is accessible through the library button on the platform. So if you will have the presentation, then you will see that all the elements and the platform itself is linked inside the presentation. The knowledge exchange part, which is the network part, is still not in place and will be implemented during this next 2 years. So the principles at the base of this work are right from the UNEP-MAP data policy, which was adopted during the conference of the parties in Antalya in 2022. And the data policy basically has the objective to support the availability of high quality data, protecting their integrity and respecting national laws, promote the adoption of fair data management practices, enable the reuse of NetMap data for the broader benefit of international community. So when we say the reuse of data, once we achieve the reuse of data, let's say, it means that we have done well all the things that went before, let's say data review, data harmonization, metadata. If other people is able to reuse our data, this means that we are doing right. So the data policy specified then which kind of data are affected, so data set expected quality, and the constraints to be respected, because since we are mixing data, not mixing, but we are putting together data from different countries, for example, we have to respect all the regional laws. So it is really important to keep in mind all these things. And then, as a general principle, data should be managed as close as possible to its source, collected once, shared with others, readily available to fulfill NetMap mandate. This means that data should be timely available, so right in time, not after a very long period after its collection, and at no cost, unless the cost of managing itself. So let's say hosting cost, data collection costs, and so on. So these are the only costs admissible for the data policy, let's say. So basically, we don't want the duplication of data and efforts, evidently, and we want to exploit already done work where possible, evidently, where licenses allow to do so, for example, and so on. But at base of all of this, there's mindshift. Since this is an open policy, open data policy, there's mindshift from data ownership, so data is mine and I preserve it on my PC, to data stewardship. Data is a public good, and I want to make it available for the broader public under an open license and for the benefit of anyone, for the benefit of the larger international community. And this is more and more true, in my opinion, as much as data is funded by public fundings. So if it's a public funded project, it's a public good. And then, as I said, data should be shared with no barriers and open licenses. Also, open licenses is an important matter, evidently especially for the reuse of data, and the data policy evidences as Creative Commons attribution as the main, let's say, license for data sharing in general, allowing any citizen and organization a full, free, and open access to it. But evidently, if data is restricted or sensitive and so on, also other licenses are admitted. And just one little point about the data policy. It is not a strict rule, but it's a soft regulation. So it's a bit more, let's say, than an indication of behavior, and it's a bit less of a real law, let's say. So it's a soft regulation. And data should be given with location whenever possible. So if for environmental data, it is common that data is georeferenced in general, but when it's not possible, evidently, this is not obligatory. The fair data management. So in the data policy, this acronym is not expressed, but all the principles, everything which is written on, is done bearing in mind this acronym. So data should be findable through the association, for example, of a persistent identifier to the resource and the indexing and research engine. In particular, the persistent identifier allows to identify univocally the element on the net whenever and wherever, let's say. So it's a sort of ID of the data, which persists in time. Data should be accessible, so there should be no barriers or less barrier than possible between the user and the data. This means that, for example, the registration on a portal should also, if it's not strictly necessary, if you don't have, for example, to manage confidential data and so on, maybe it's not useful. So the accessibility, it's really important. The interoperability, so through the use of standards and machine actionable metadata. So interoperability basically passes through, it's the communication among machine or among systems. So if the machines speak the same language, let's say the standard is a sort of language, the machine can speak each other. So a system is, some systems are interoperable when they can speak the same language. So they use same international agreed standards. And reusable, evidently, through the use of meaningful metadata and appropriate data licenses. So the compilation of metadata by means of also their internationally agreed standards, it is really important to understand the reliability of data and to have more indication on how to reuse this data, how these data are exactly reliable. And the use of evidently appropriate data licenses. So I have to associate data license that allows me to reuse data. So the preparatory activities for the implementation of this prototype are of two types. So first of all, thanks to the work of the data management working group, which was composed from basically components from the other regional activity centers, we accomplished the data discovery. So we both studied the heritage of geographical and documental data, the data quantification and qualification. So we characterized data in this matter, and then we metadated them, applicating standard common practices where possible, evidently. And this is towards the data harmonization, which is still not completely achieved, but it is, these activities are preparatory, let's say, to data harmonization. Then, thanks to all of this, we created, once we had an idea of what our knowledge heritage was, we hypothesized potential users for the platform. We hypothesized their potential interest inside the platform. So what can a citizen or a community of interest would search inside the platform, would want from the platform. And then we depicted some use cases that we selected. And thanks to all this work, we identified some access level to the platform, starting from the ones of the InfoMap Node SDI, when the InfoMap Node SDI is a spatial data infrastructure that was in place and then become the center of the data hub, which is still in place from Inforac, and it is the center of the data hub of the knowledge management platform. So we identified different level of access, level activities that can be done from the user inside the platform. So if the user can upload, edit, delete data, can view, download, and set privileges. Evidently, this last one is only the administrator. But anyway, so we defined all of this, and then we created. I'm sorry because I have this very, oh my god, very unuseful part of the Zoom that tells me there's a question on chat. Yes, thanks, but I would like to see my presentation. Sorry. Anyway, then we created the logic behind the platform, a search and retrieval logic, let's say, of information behind the platform, and we tested it after a survey that we created a sort of graph also in this case, and we created the survey hypothesizing some missions that should be accomplished, and we give a scoring to the mission itself. So in reason of the elements that have been retrieved from the platform. So for example, the head of the Scuba Diving Association had to plan the future excursion looking for corals. So he will look for maps. They will look for maps. They will look maps of the bed of the seabed. They will look for reports about the presence of corals and so on. So let's say all of this. And based on this survey, we set up this logic, but it's never too late to contribute because the survey is still open. So if you want to test it, you can. The K-map products, the K-map final products are basically two types of products, evidently. Georeference products, so layer, maps, geostories, dashboard, and remote services, and documents. For what concerns layers and maps, a layer is a single data set, for example, one shapefile, which is basically an information without a context. So inside the pyramid of knowledge, it is basically data. A map, on the other hand, is a superimposition of layers, resulting in a combination of datasets with a specific communication aim. So it's data in context. This means that this is information. So there are
2 minutes
stories.
remaining, Annalisa.
Yes,
Two
sorry?
minutes. 2 minutes remaining, please.
I cannot hear
I
you.
was saying
Sorry?
2 minutes remaining.
Okay. Wow. Okay, I'm a bit late. So the K-map products, then there's also the GeoStories, which is a powerful navigation instrument that combines text, interactive maps, websites, and so on. The dashboards, which provide charts, maps, tables, all related to, for example, a map, and then they are reactive to the map browsing. So if I zoom, for example, in a specific zone, then these graphs will change accordingly. Then there are documents. One important thing is that all the documents have been linked and not harvested in the way that they are managed near to their source. And the library implements also full text or search, able to retrieve documents also based on their comments. And so there's possibility to link the resources, for example, the same document in many languages and so on. And then the remote services. K-map links many remote layers from other portals and other platforms through GeoServers. So let's speak about geographical layers. We also offer remote services of our data, where evidently available. The K-map architecture, so the Data Hub is dealing with geographical layers, map, and GeoStories, and the Knowledge Hub is dealing with documents. Basically, from the home page, it is still possible to free text search all the platform contents, and the hubs are accessible to the two buttons. And the third hub will be developed, so the network button, which is a sort of place where stakeholders, citizens, and UNEP map meet in the end, which is think in this way, thought in this way. And then in this first prototype is not included, but will be implemented in the next 2 years. Then there are also other filters. You can search by themes, and the filters are different for maps and library parts. We put it together, so incorporated different data sets, both public and less public. For example, the last MEDQSR, so the quality status report of the Mediterranean, there are some sort of 200 or more restricted layers on the platform. And then for what concerns the software, the platform takes advantage of PostgreSQL, PostGIS as a database, GeoServer as a manager for the database, and the software that allows to have interoperable standards for geographical data. GeoNode, which is a full stack CMS, which is basically our interface to GeoServer, and MapStore, which allows the creation of GeoStories and dashboard. And all the documents from a map documental heritage are referenced, indexed, not only on title and keywords, but also on the abstract where available and on its content by means of PostgreSQL. And InfoMap producers and roles, so all the things that were in the Data Hub, in the previous Data Hub of UNEP Map InfoRack systems, have been preserved into the actual platform. So what's next? A set of actions are already in progress, such as the creation of a power user group for the testing of the platform. The incorporation of an AI engine for better navigation of both geographical and documental data, and the creation of the third hub, which is the network hub. So these are our ideas. So still on paper, and we will be available during the next year. And for the next future, in the meantime, we aim to create a single sign-on system for the access with one username and password on all the InfoMap platforms. So which is not only the KMAP, but we also have IMAP info system, for example, at informatic level, obviously, at IT level, and all the other BCRS and NBB and NNB systems. So the creation of an ecosystem of microservices talking one each other. We, for example, hypothesized to implement the Jupyter Lab, which is actually on the IMAP platform, IMAP infosystem platform, so resides in IMAP, and we want to use it with the KMAP data. Make the whole system scalable and easy replicable in all its parts through the use, for example, of a Kubernetes architecture. I thank you all for the attention. I hope to be okay with the timing. I'm not sure.
No, thank you first, Annalisa. Everything was good. Thank you for having presented this KMAP, let's say, gate and platform, which is intended not only to decision makers, but also to public, to scientists, to researchers, who can find different type of data, either they are GIS type or even documentation, etc., about everything that has been collected in the Mediterranean about the protection of the Mediterranean biodiversity. So, do you have any question from the room? Okay, any question from the online participants?
I saw something on the chat. It was for me.
No, nothing on the chat, Annalisa. Well, so I will take the floor and ask you a question if I can. Well, you have presented the KMAP system, how you have been thinking it, how you managed all the preparatory work to develop it, to be able to obtain such result. But could you elaborate a little bit about the challenges that faced you during the preparation and the implementation of this KMAP prototype? And tell us how your team overcame them to ensure effective data management and dissemination. Thank you.
Okay, so for the first part, for the first question, we faced some challenges because it was really, inside the NetMap, as you clearly know, we work on many different topics. So the problem is that also data is very diversified. So we have reports, guidelines, we have point sampled. So we have really a wide panorama of things that we had to try to put together. So this is the reason basically why data harmonization is still in progress. So it's not easy to put together all of this. So this is, I would say, the main challenge we had to face during the implementation. So and other challenges sometimes are referred to data management itself, because we approved this data policy in 2022, and all the countries agreed on this data policy, but sometimes, so the data policy is written a bit in legalese, you know, it's not a human readable, it's a citizen readable language, let's say. Also, politicians have some difficulties, in my opinion. And we had done a lot of dissemination. We are doing a lot of dissemination about what is written inside data policy and what this implies for data management of the single countries. So this means, for example, that if I agreed on an open data license and I have not sensitive data, I have to release them as open data, so with a CC BY license. So, and this is somehow difficult still to understand. And this is, a bit difficult. But anyway, I found that people took quite good this novelty, so the novelty of the platform, and this was a good thing for us to. It was a good feedback to go ahead with our work, basically. So, I don't know if I answered to all the questions.
Thank you, Annalisa. I see first that Dory on the online is raising his hand. So please, Dory, if you have any question.
Thank you. Annalisa, thank you for presenting this tool. It looks very, very promising. I was wondering whether you came across anything that was specific to citizen science, because in the upcoming EXA convention in Vienna, we're going to have a breakout session and workshop on standardization and harmonization. And if you have any insights that are citizen science unique, we would love to incorporate them and, of course, invite you to weigh in.
So we have some systems producing citizen science data, for example, for UNetMap. For example, the one is the Sea Watcher app. Maybe I can show a bit, just a second. I don't know if I'm a bit late. But anyway, this is the UNetMap Infrac Sea Watcher app, but then we will see evidently other things. We still have not incorporated this data inside the platform, but we plan to. The matter of the citizen science data it's quite difficult, let's say, to especially to harmonize. But we believe that if data is well metadated, so it means that data is taken from the citizen, let's say, and the only warranty, let's say, on data about quality is given by the citizen itself, so the collector itself. I think this is not the problem for the incorporation inside the platform, because you know what you are going to use or reuse. So it's all a matter of knowing about what you're dealing with, in my opinion, from data management point of view, evidently. So this is more or less my point of view.
Thank you.
Thank you, Annalisa. I see we also have a question online from Fernando, who's asking about the possibility to consider sharing the knowledge that is inserted on the KeyMap platform with other similar platforms in order to develop a global knowledge network.
Absolutely, yes. So when I spoke about remote services, I just meant this. So for the moment, it's not for the moment, it's in general. We have a geo server behind the platform that allows for interoperable service. This means WFS basically and WMS data, but there's also the possibility for WCS, so web coverage services, and WPS, so web processing services, to share data of the platform with other platforms. So they are already available basically through a link that you can incorporate inside your platform, and you can, let's say, have an image of the data which is contained inside the platform. And the platform itself takes advantage of many remote services. For the documental part, on the other hand, we ourselves, we linked documents. So it's not us which are sharing data, but the platforms, the libraries, and the other systems of the RACs, of the other regional activity centers, which are sharing their documents inside the platform. So we only linked the elements in reason of the principles that data should be managed as close as possible to its source. So.
Okay, thank you, Annalisa. I think we will take one last question from the room. Please, Aysam.
Okay, it is in a Q&A question from a Q&A session. It is about if you can share the link of the platform. Thank you.
For sure. For sure. It is already on the presentation, but I will put it on the chat. So, I don't know, because now it's only with Secretariat, but I want to meeting room, maybe. I don't know.
To all.
Yeah, there's all somewhere. Organizzatore relator? No. There's meeting room in my chat. I don't know. It's a direct message. Not with meeting room. Anyway, I will do it during the.
It is done to everyone.
Yeah, thanks. I will find a way.
Okay, so thank you, Annalisa.
Thanks.
I think it is time for us to go to the next slide, to the next presentation, which is will be about the fascinating case of oceanographic visualization with focus on 3D immersive tool designed for digital twins, employing virtual choreographies. So, Mr. Fernando Cassola from Inesc Tech, welcome. Are you hearing us?
Yes, perfectly. Good morning. Are you hearing me well also?
Yeah, perfect. So I will ask you then to take us for deep dive within this subject. Please just try to fit on to the time, 15 minutes.
Okay.
Thank you very much.
Thank you. You are seeing my slides, right?
Okay, so.
Okay. Good morning. First of all, good morning, and I would like to thank you for giving us the opportunity to present our research work within the scope of the Iliad project. Well, also, it is with great regret that I cannot be physically present with you, but we have to thank the technologies for allowing us to communicate in this way. Well, this presentation will show what we are developing in terms of the issue of the oil spills, namely through the creation of an immersive tool for digital twins using virtual choreographies. My name is Fernando Cassola, and I'm also here on behalf of a vast team that has been involved. Well, studying and understanding the dynamics of the oceans is a tremendous challenge, as we come to realize through the previous sessions and presentations, and requires also advanced technologies and innovative methods for collecting, for processing, and also to representing data. In this context, the digital twins of the oceans emerge as they intend to show data from various sources, being of course heterogeneous through a digital representation. But how can we visualize and interact with these various data sources? It is then that we have been investigating, researching in order to answer to that question. Well, within the scope of Iliad project, as I said, we have developed and implemented this pipeline that aims to create an innovative concept in that having its origin, well, its origin, the raw data that comes to us from various sources, several sources. It is then worked through the execution models, thus generating meaningful data. Consequently, after choosing the data that pretends to be visualized, we apply a transformation according to the desired output, following the creation of the virtual choreography. I will explain later what is about the virtual choreography. Once the base virtual choreography has been generated, the tool that will visualize this data will have to interpret this data so that it can be visualized on different platforms, such as Unity, 3GS, WebGL, Unreal, etc. But considering that we have introduced an innovative concept here, let's see what we mean by virtual choreographies. Well, virtual choreographies are sets of interconnected behaviors, interaction, and events that take place or even taken place in a certain time and space with certain objectives. The way we do this registration is using the Experience API that was developed within the scope of the United States Department of Defense, and that has been mostly used to represent behaviors in teaching support platforms. However, our approach, based on this implementation, currently carries an innovative approach in that it makes it possible to represent any type of event as long as it contains actors, real or digital, and that they take place at a certain time. In this oil spill use case, we have, for instance, the following actors: an oil spill, and eventually, if it exists in certain geographic areas, ships, vessels that could have also independent behaviors. In the context of this research work, we have developed the virtual choreographies as an extended API syntax to aggregate static files and dynamic streams, data elements, mapping them to sequence of events and actions performed by actors at a given place and time. This approach provides the context and narrative to heterogeneous ocean data to facilitate the user's immersive exploration of data, behaviors, and patterns. But how do we implement this approach? Let's now take a closer look. Well, after receiving the data for a given area, we transform the information into a simulation of a 3D particle system that evolves over the time. At the same time, based on the particle systems, we generate density contours and also temporal snapshots where the moments when the particles change shape and or density are marked. So in a nutshell, we can say that this system allows us to receive netCDF files that contain simulations of oil slicks, bathymetry, coastal areas, and points of interest, allowing the end user to choose of a certain geographical area and type of visualization that they want to perform. Consequently, the limits of the oil spills are generated according to the density, the particle systems, and the bathymetry, and it is still allowed. Our method is supported by a conceptual visualization pipeline that receives historical, real-time, or forecasted oil spill spatio-temporal data that generates density isolines of the evolution over time and maps into a virtual choreography together with relevant content. This is where the issue of visual metaphor comes in. That is the mechanism that, by choosing the type of visualization compatible with the intended geospatial area, will generate the virtual choreography that enables the rendering of all the previous mentioned files, regardless of the intended visualization platform. The visualization tool interprets the virtual choreography following a model-driven principles via ontology mapping formal models, transforming language, partial order planning, or hierarchical state machines, thus allowing the information contained in it to be envisioned in a platform-specific representation. Currently, and let's make here playing. Currently, we are able to visualize within the same virtual choreography, that is with the same data source, on two different platforms, Unity with a more immersive form, and in a browser, allowing us visualization in any support type, computer, tablet, or smartphone. We are currently creating another viewer, but instead of showing the boundaries of the oil spills, it will make it possible to see particles based on the same approach as the virtual choreography. Well, so yeah. Here we can see the demonstrators running the same dice as we see the same dice, the same choreography in the oil spill. Well, pursuing the development of our unified platform, we are also creating a tool that allows us to tracking the pipeline that I described earlier through the different types of scenarios, whether it's to visualize foresting data where in new scenarios are generated, or for instance, viewing real data, or when data becomes available, it will be possible to select the spatial temporal area that we want to view. Then choosing the visualization tool available for that type of information and obviously the location. Well, we demonstrate the potential of our solution in a 3D immersive environment with an oil spill use case where simulations and forecasts can be fully explored by stakeholders such as decision makers, etc. This solution is an efficient way to represent behaviors and associated visual mappings while being neutral from a rendering technology perspective. It offers a declarative approach that does not require additional programming or computer or compiling when changes, data elements, event behaviors, actors, mappings, etc. are performed. It is suited for federated and distributed digital twins where the need to display same information across multiple and heterogeneous platforms is required. Here we have a demonstration where we have a longer timeline, and through an immersive way we can follow the evolution of the oil spill and in a certain georeferenced area and on a certain day or time. Well, that's it. Thank you for your time. Any questions?
Thank you very much. Thank you for this marvelous presentation. Indeed, the integration of these virtual choreographies into GTO data visualization is indeed intriguing. So could you, prior to my question, is there any question from the meeting room? Yeah, I see there is one, please.
Thank you very much, Fernando. That was an excellent presentation. As you know, in video production and immersive media productions, often a storyboard is created first with key snapshots of the visuals that are then later shot with real cameras. Is there something similar where in the virtual choreography tooling that you presented today, you can build a sequence that guides the actual rendering implementation?
Yes, it is possible. Yes, the idea, it is possible to, let's say, make as we have the choreographies such as in a dance floor, for instance, that are a set of behaviors and sequence behaviors, yet it is possible to map those forward behaviors in a certain place or a time. So it is possible, if I understand your question.
Yeah, because that, I mean, you've created a beautiful kitchen with a mise en place of ingredients, but now the proof of the pudding is in the eating, I guess. So is the experience significantly better now that we have this fancy kitchen that you built for us?
Yes, because we can immerse inside that menu that we have built up. So it is possible to be immersive inside the platform, and even we can change some of the setup that has been done. For instance, the waves and the winds, and that could eventually create a new what-if scenarios. For instance, if the wind changes, what happens to this oil spill? Or if we have models to pursue that changing, we can also visualize them under that new scenario. Yeah.
Okay, thank you.
You're welcome. Thank you.
Yeah, I see we have another question from the room, maybe two. Aysam, please.
Right. Thank you for this presentation and for the video simulation. So I'm wondering, for the case of oil spill, if you have, for example, satellite images for validation of the model that validate the accuracy of the flow of the oil spill into the water. Thank you.
Yes, we are using NetCDF files that are used that have been generated by models that are several types of sources of models. But we are using that data. Yeah. This one that we are seeing is not, it's just a demo, but yet we are actually running with real models.
Anis, please.
Thank you, Fernando, for this very interesting and very good example. I saw that in your simulation, it's very good to be prepared to assess what could happen, so what if scenarios. But I'm wondering if this simulator could evolve to be more dynamic. I mean, when unfortunately this kind of oil spill is happening, can this simulator also be used during the intervention? Because we are trying to avoid oil spill, we are trying to limit the impact during the intervention, but I see that this could be a very good potential also, if it is also dynamic, because you know very well when there is very bad weather, it's quite difficult to assess what is really happening, and this kind of models could be very, very useful at that right moment. Thank you.
Yeah, this platform, if we have that data or even the data that show us different types of scenarios, we can generate this simulation with this simulation tool, just having the sources because the sources are outside of the visualization tool. So we can insert new behaviors, new actors also. For instance, if we have a model that allow us to put some barriers outside the oil spill, if the model is feasible to that, we can insert those actors those barriers, and the model changes, exactly runs the oil spill, and it can evolve and understand what is happening without the need of the new compilation tool, without need of new programming. Okay, it's feasible to do that. Yeah.
Thank you very
it's
much.
Agnostic from the sources. Yeah.
Thank you very much. I don't know. I see that online we do not have any question. So any other question here in the room? Otherwise, we go to the next presentation. So I now call upon Garabet Kazanjian from the American University of Armenia to present. Hello. Can we see you? You will present the digital twins on the ocean for multi-sectoral governance and policy making. So you can share your screen directly.
Mm-hmm.
Yeah, we can see you too.
My slides.
Nice to meet you.
Okay.
Well, so the floor is yours.
Thank you. Thanks a lot for the opportunity to present already some of the work which has already been shown from Iliad. But today what I wanted to talk about was how all of this leads to policy impact and roadmap towards multi-sectoral governance and policy making, how digital twins could contribute into this. So as already noted, my name is Garabet Kazanjian. I'm an assistant professor at the American University of Armenia. And among other things, within the Iliad project, I'm facilitating the policy impact of the project. It was very fortunate that Fernando presented right before me, because he already made it a lot easier to understand what I'm going to talk about today in action. What I want to do now is take his presentation and move forward to elaborate how all of this could be used by policymakers and public authorities. So I'm sure you've already heard a lot about Iliad and digital twins, but just for clarity's sake, I'll be very brief in explaining what the whole thing entails. Iliad technically provides virtual representations of the ocean capable of running complex predictive management scenarios. And already there was a question from Anis just now about what if scenarios. I'm going to elaborate on that a lot more in my presentation. So the system integrates cross-disciplinary sensors, models, digital infrastructures, and it's all built on a federated system of systems where using similar standards, APIs, and best practices, a lot of data or models could talk to each other and integrate into building new services. Iliad also wants to partner with a number of different projects and communities towards implementation of interoperable systems, services, and assets. So in a nutshell, we want to create a number of interoperable digital twins by connecting to already existing ocean data infrastructures, but then also enhancing these infrastructures by additional observation data, whether that comes from low-cost sensors, citizen science, etc. This was already discussed again in a few talks ago. And then all of these services will be hosted on a marketplace where a lot of innovative methods and open frameworks will be developed and showcased and also commercialized. But then this marketplace will also enable model evaluations, comparisons of different applications, etc., etc. And then we want to build a community, a social community around all of this, coming from a very diverse set of end users to help test, develop further innovative ideas, and progress policy even further. For that, we're also creating a small facility hub. We are calling it the Business Technology and Innovation Facility, where a lot of startups or university early career researchers could, if they have specific ideas within these realms, could integrate into this project and develop their ideas further, getting a lot of help from our end. I'll talk a bit about that more in a second. So this is how the marketplace will look like, and it's going to go public very soon. It's kind of in an internal beta testing at this point, where a lot of the services are going to be hosted. It's some sort of a catalog where you have different tags and different search capabilities with regards to sectors or geographic areas, etc. And then if you search what you're looking for, all the relevant hits will come up where you can download the data if it's freely available, or in a commercial sense, you can also buy some of the services. On top of the marketplace, we also have a number of pilot case studies. Fernando already showcased one, but this isn't only closed from an Iliad perspective. Like I said, if you have already some sort of a prototype or an idea you want to test, you can actually contact us to go into this program here that you see called Twin Labs on the bottom right corner, where it's some sort of a beta testing. You can have access to our platform and then get a lot of feedback. Once the product is deemed already mature enough, then it could eventually be hosted also on the marketplace. So to start populating the marketplace, and as you've already seen throughout the last few days, there's a number of different Iliad pilots which are dealing from a very different number of sectors, coming from renewable energy to fisheries and aquaculture, marine traffic and harbor safety. So Valentine also represented something about ballast water in the morning, pollution, met-ocean data, biodiversity, insurance, and other maritime activities. So altogether, all of these very rich, very innovative solutions, how do they contribute to policy advancement, is the question that I want to deal with today. So obviously our objective is to support the planning and decision-making of blue growth to meet specific European environmental and socioeconomic objectives, but not only European. Obviously, there's also regional and international targets like the UN Decade of the Ocean and such. And we want to work very closely with end user groups and stakeholders, specifically policy stakeholders, to make sure they can take full advantage of these solutions and tools. So in one way where Iliad could contribute to this is help making environmental data widely available and accessible via bringing in data from multiple sources, whether these are marine observatories, national libraries or repositories, Earth observation systems, etc., and making everything function in an interoperable way, following common standards and FAIR principles for increased accessibility. On top of the available information and data sets, we are also looking into integrating additional new sources of data via deployment of low-cost sensors, IoT devices, citizen-generated data and such, with the addition of appropriate tools for their validation and analysis and integration into the models. Thirdly, we also want to help compliance reporting and implementation of legislation, and this could be used by public authorities, regional administrators, policymakers, and so on, where they could actually see in near real time what is happening and follow up the situation in the sea. But also businesses could access some of the same applications as the policymakers, and this could help bridge the gaps, so to speak, where businesses are reporting in the same toolkits as public authorities, and everybody has access to the same information and infrastructure. In the future, we are also discussing integration of third-party solutions. A couple of weeks ago, we had during the GFCM Fish Forum, we organized a workshop with FAO's Calypso team, where we were also discussing how their project of reporting fisheries data for national authorities could be somehow complemented by Iliad solutions. Fourthly, we obviously, and this is something Fernando showed very well, is visualizing complex environmental data for ease of understanding, ecosystem, and domain interconnectedness, where a lot of very complex algorithms and models could be displayed in a very nice, easy to understand visual toolkits, aiding policymakers to make sense of the situation and what needs to be done. And then these domain interconnectedness and a kind of a holistic vision would help highlight policy gaps and potential conflicts among different international or EU and national legislation, including between EU member states and neighboring countries. For instance, when we're talking about the Mediterranean, where we have both parties, EU member states and non-EU neighboring members. But all this said, I think what digital twins really come to shine are the next two examples. The first one, which Anis already highlighted briefly before my presentation, is the what-if scenarios. So digital twins could help create or analyze what-if scenarios to support decision-making under uncertain conditions. And this could entail, for instance, forecasting future impacts of climate change on different sectors, so whether that's fish stocks, biodiversity, water quality, etc. We could also forecast adverse events like adverse weather events or oil spills. That was already shown. We could forecast potential impacts of new legislation. If we implement this particular law, what would be the impact of all of that on, for instance, biodiversity or fish stocks? And lastly, we could look into, for instance, marine protected areas and how all of that would reflect if this area is protected on different sectors, as mentioned. Secondly, what now we need to kind of move towards this direction is moving from one pressure point, one fish stock assessment or one potential pollution assessment to a more holistic ecosystem approach. And that cannot be done realistically if we're not looking into cross-sectoral, multi-layered governance. And in this sense, digital twins help with analyzing the impact of one sector over other sectors. And this is also needed in terms of governance transitioning from a more siloed approach of looking into each sector separately, whether that's fisheries or tourism or maritime activities, etc., and looking into ocean governance in its totality with regards to how all of these sectors interplay. So digital twins could help analyze the impact of potential upcoming changes and forecasts on multiple sectors. And also, if we want to go one level further, we can also look into not just environmental, but also economic and social perspectives. So I'm going to showcase a few case studies here. One of them, the first one is the Norway aquaculture pilot studies that we have within our project. The aquaculture industry is about a bit less than 10 billion euro industry in Norway alone. However, with climate change impacts, they're facing increased risks and more complex hazards with regards to both disease control and other impacts. So there is a very strong need, not just from the fish farmers, but also the insurance companies on how to estimate the risks so they could sell their insurance packages. So what this pilot has achieved, and this has been a collaboration between multiple different companies and institutions, is to build better predictive analytics to ensure compliance, sustainability, and a profitable future for the industry, both fish farmers and also the insurers. So on the right-hand, top right-hand corner, you see, for instance, the forecasting of transmission of diseases, of lice from one aquaculture farm towards other aquaculture farms within the fjords in Norway. On the bottom, in the bottom figure, you could see the temperature variations and forecasts that are coming. So all of this is going to impact different fisheries and fish farms, and also all of this is culminated in very easy to read dashboards where both farmers and decision makers could look into the data, could check the compliance, and could also look into forecasts. And based on these forecasts, insurance companies could identify future risk scenarios and adapt their tailored insurance packages to each of the farmers accordingly, analyzing each scenario and each forecasted possibility within their portfolios. Other examples that I could give was actually something done in Al Hoceima in Morocco last year during the summer school that we organized there, where the participants looked into the impacts of shellfish farming on the marine protected area. Other potential examples could also be, for instance, the impact of ship routing on marine traffic and marine traffic on fish stocks or marine biodiversity, the impact of offshore renewable energy projects on other sectors, again, biodiversity, fishing, tourism, etc. So all of these are just, we're scraping the surface of the barrel here, but they're all potential ideas of how digital twins could help policymakers from moving from more boxed, siloed approach into looking of more holistic governance model in a multi-sectoral way, where they also bring in future risk cases into their analyses and thereby come up with better decisions which mitigate these potential future occurrences. So what steps is the Iliad project taking to ensure greater policy impact? We're working on a number of different policy toolkits, which are more theme related. So for instance, with fisheries, we're going to develop one policy toolkit. With renewable energy, we're going to develop another, where we reach out to policymakers and in a co-design aspect, develop specific guidelines of how they could use these solutions for policy setting or for policy compliance. Apart from that, we've also been working on developing policy briefs, broadcasts, and newsletters to update every stakeholder who's interested in these types of projects with regards to the development of our solutions and where we are, how the prototypes are working, etc., if they want to test them out. And we're very interested in end users testing our services because the feedback will only improve the products themselves. We've also organized a big number of workshops and webinars, both for internal capacity development, but also for external parties. Everything is open and available online. Whoever wants to learn more about these technologies and how they could be used in a number of different ways, they could follow these webinars. And we're very actively contributing to European policy dialogue and action agendas. For instance, I'm currently now in Brussels participating in the Mission Ocean Forum, and digital twins are a very hot topic with regards to governance. Further on, we've also organized a number of trainings and workshops. Again, most of these workshops are available online if you want to have access to previous events. We organized a summer school in Morocco last year, and we will organize another summer school this year. If you're interested in that, these are mainly aimed at graduate students, PhD students, and early career scientists. If you have students of your own who might be interested of participating, please register and keep your eyes open for more details to come. Other than that, we've already organized a number of hackathons. We organized one during the summer school, as mentioned last year. We participated in the Cassini hackathons, and there are 2-3 more coming this year. The next one will be on business development and innovation of these tools, but there will be some technical ones also to come, and probably a policy one to come later this year. Lastly, we are also working on developing or building a policy impact facility page, where a lot of the policy briefs and broadcasts we've been producing could end up there. So policymakers could simply go to that page and understand how all of this and all of the different solutions could help them in their everyday work. We've already mapped the stakeholders in each sector that we've identified and we want to reach out, or we've been reaching out to. But also in this mapping, we're looking into how different ILIAD pilots and projects and solutions could touch upon different policies, whether that's European policies, UN or international policies, in a very nice visual form, to kind of assess the impact of what this type of work could have on policy advancement in a national, regional, and international level. This page is still under development, but it should come online soon in the coming months. One more thing, I talked already about trainings and workshops. Part of that, or all of that, will eventually end up in something called the ILIAD Academy. This is very close to being deployed, where a lot of the training material we've been working on will end up being curated into online courses and MOOCs, and will end up on the Academy page. This is an educational and capacity development hub for the project, but also beyond. And it will host content related to ocean digitization, twinning, marine sustainability, blue economies. So if you're also educators or work within universities or develop any type of online course content, we would be very happy to host it there for greater exposure. Technically, the ILIAD Academy will host anything related to marine sustainability and digitization. So this is my last slide. I would just like to raise your attention to a couple of recent events we had organized. We've sent out policy briefs to targeted stakeholders of how digital twins could help policymakers. We organized a workshop on ILIAD applications as tools for policymakers last November. This is an online workshop which is available on YouTube. You could access it easily. This was specifically the case of fisheries, but similar ones will come for other sectors. As I mentioned before, we organized a workshop at the GFCM Fish Forum in collaboration with UNEP-MAPS PARAC and also the FAO Calypso team. There we had a lot of very interesting discussions and also testimonials and input from fishermen that are using some of these tools, how it's helped them. And there were very interesting discussions on building trust between fishing communities, policymakers, how the tech industry could kind of bridge the gap. There will be a number of different policy briefs coming as a result of this, so stay tuned. And our idea or roadmap in the next months is to select different teams and highlight these pilots within these teams to the general audience, specifically from a policy perspective. And like I mentioned, all of that will eventually end up on the Policy Impact Hub page. So that was it in a very quick and summarized way, how such a big project and innovative tools could help with policymaking. I'm sure there might be a lot more ideas coming up in the coming months, but if you're interested in reaching out or collaborating in different ways, organizing joint workshops, etc., or interested in simply some of the training material, feel free to reach out. These are my contacts, and I would be very happy to answer any questions that you might have now. Thank you.
Thank you very much, Garabet, for this impressive
presentation of this wide board of applications of the Iliad DTOs. Is there any question in the room? Yeah, Aysam, please.
Thank you, Garabet, for this nice presentation and for showing the, let's say, the link between DTO's initiatives and the policy impact, and what could a digital twin initiative can help in the process of decision making and how it can facilitate this process. Well, I think it's a long path, but due to the, let's say, uncertainties in models, so it leads also to uncertainties for decision making. So it is a long path, but it is, in the end, we should start this path in order to lead to better decision, because it's a must. So my question would be, with regards with the policy legislation, how can the DTO initiatives, let's say, help improving the gap in knowledge in legislation?
Okay. If I understood you correctly, how can DTOs help in identifying gaps in legislation?
Yes, in knowledge, because we are not aware of all the legislation that exists around the world. For example, for let's say the example of Mediterranean Sea, for example, and for other regional seas and oceans. So how it can help in reducing this gap in knowledge.
Okay. I'll answer this in a bit more indirect way, and let me know if it makes sense. So what DTOs could do, first and foremost, is visualize the situation on the ground and look into forecasts. What they could also do is, when you integrate different parameters, for instance, the impacts of climate change on biodiversity or different sectors, there you could highlight that within certain conditions, the situation will not end up well. So on one hand, this will very clearly demonstrate, obviously with some uncertainties, but it will demonstrate to policymakers that the current legislation is not enough. So if, for instance, with the surface water temperature warming up by 2 degrees, these will be the impacts on these fish stocks, this will be the impact on biodiversity, this will be the impact on water quality, it will very clearly showcase that the current legislation is not enough to mitigate the impact which is going to happen in, say, 20 years or 30 years under these conditions. So this is on one hand. The other case would be to see or visualize all of this in a more holistic way, as in not from only a national perspective or not only from one sector perspective, but also, as you mentioned, in the Mediterranean. So how, for instance, fish stocks are migrating. We're not only looking into marine protected areas, but we're looking into a much bigger regional zone. This will interplay how different national legislations are kind of coherent with each other, or we're doing something correct here, but in other areas, the impact is being kind of pushed back. So taking a more zoomed out view of things and looking into this from, again, multi-sectoral perspective and multi-layered perspective, a lot of these maybe not gaps, but restrictions or lack of proper implementations would be showcased in a clearer way versus looking into something in a much more narrow lens. So I think in this sense, digital twins via visualizing and forecasting what's going to happen in the coming years or decades and under different scenarios would highlight for policymakers the need for improving legislation or covering gaps or conflicts that might happen on a wider regional scale. I don't know if that kind of answered my question.
Thank you very much, Garabet. I think, we all got the sense of your answer. Well, due to time, we have to go to the latest, presentation for today. We will be back to Mr. Valentine, who will enrich us about the intersection of technology and citizen engagement in ocean governance, and the Ramani extensive experience in co-creating smart home applications to mobilize citizen participation in reporting ocean observation. So, please, Valentine.
Thank you again. So these this work follows on the talk of Garabet and others who present already. Particularly, Garabet mentioned the Cassini Hackathon as an example of an international competition event, which we also took part in as jury members and as coaches. But before we go into the nitty-gritty of citizen science and how smartphone applications might help transfer and convey maritime information needs, and of course bring the decision-ready information to where the decision maker is, either in the port or on a boat or on an MPA, assessing the situation on the ground and making decisions. Let's first look at an example of an international competition event we did last year. Next slide, please. So in November of 2023, we did not only do the Cassini Hackathon mentioned earlier, but we also worked together with Firdaus, Veerman, and other co-authors, presenting how do we take this trove of and wealth of Copernicus data further and bring it to where small medium enterprises and NGOs and public agents are in a boat at the port. And how do we engage them as stakeholders not only to use this information but also report back. No audio, so it seems. No audio, so it seems. You want me to log in online? All right, anyhow. Well, here you see a few slides in the video presented. This is a kelp forest citizen science initiative. We also engaged space and other industry players. This was leading to various forms of smartphone applications that tried to bring a critical mass of information to the table to help engage people. So let's move on to the next slide, please. So far we've heard a lot about the Earth information community, so the oceanographic and the atmospheric sciences domains. But to be able to do citizen science, you also have to realize you've got to bring in the geospatial information community. So that is the work we started. Next slide, please. To make these two worlds more interoperable and to find a way of this data being shared, we developed an interoperable middleware that harvests data from one catalog from the geospatial information community into the other, the Earth science community, and vice versa. Once we've got this building block, we can then start sharing space sensors, motion and other IoT or camera sensors, and now, of course, the human sensor, which sounds a bit degrading, as if we are only seeing things and observing things, but obviously there's more at play. Humans are also stakeholders and decision makers, and so we looked at how do you engage citizens. And in the previous presentations, and that's often the take that citizens are perhaps complaining about, is that scientists generally see their engagement as a simple means of producing the validation data to fill our data gaps. And we forget they are themselves curious and engaging human beings that may help in so many ways. So let's look at what are citizen science roles we could and functions we could identify. So just a random list. Means of citizens to express their concerns, such as the question raised earlier by Garabet, what if the ocean changes with these climate change projections in place? Will I still be able to eat the fish that I'm used to? How expensive will my fish become if I'm not buying it through the retail channel, but perhaps straight from ports? Should I consider or be concerned about the plastic that may end up in the ocean, and what is my role therein? And of course, the policy maker and impact businesses on the pollution levels, etc. So social stability is also guaranteed, or at least promoted, if citizens become part and parcel of the solution and they have a sense of ownership and agency for change. So these are just a random list of examples of how citizen science might be perhaps perceived in a more useful and operational manner. But at the end of the day, we shouldn't assume citizen science is always appropriate. First and foremost, it takes a lot of time and effort to engage them. Well, there are many examples of people here in this room and in the audience who've done so with great pains and efforts. So the hooray and an applause to them. Also, as I mentioned earlier, the data we collect through citizen engagement is not necessarily solving our needs as scientists, like we need our models to be validated and we don't have the observation. So let's use citizen science as a nice surrogate replacement. The risks of exploitative use of citizens in science projects is that they become interview fatigue, so to say. And so we should take great care in our engagement efforts. If it's inefficient, or if there's no demand for the data by the citizens that we scientists hope to collect, we should be wary to think about what is the return and what is the value we give to them. So here are a few examples just from this forum alone over the last 2-3 days. Clyde from, Vlis, not Vouw, the example of the Belgium fisher fleet. Instead of thinking like a scientist, our first and foremost focus was to create value for the vessel owners. We felt that if they were really helped, the trust with our automatic catch monitoring techniques would come naturally. To build up the trust, we pivoted our approach, ensuring that all data ownership lies with the vessel owners. We're evolving towards a more positive relationship before touching upon more sensitive subjects, such as benthic cover impact of trolling. And so from 5 vessels, we're now in the process of onboarding 37 out of the 60. So this is just testimony to people in the audience and in the domain understanding that unless we bring the value to the stakeholders and citizens and the SMEs first, there's no way of expecting any scientific data back down the line. Jean-Laurent from Vouw, the Calypso SEO presentation, our challenge at Vouw is to engage the fisher to report back his observations. Not just the commercial catch, but also any bycatch to understand the pressures on the ecosystem better. So again, an example of someone who realized our previous efforts failed because there was no critical mass of value to get people to open their app and to report back. In this case, bycatch, which is, as Laurent rightly put, very important for his scientific endeavors, but not of interest to the fishermen. So unless we bring some value to the fisherman for him to open the app, don't expect the other data to come as well. So here are some existing frameworks to consider to fully understand the breadth and width of citizen science in different pilots within the Iliad project. And this was co-produced with Stephen Parkinson from Earthwatch, our partner in Iliad. So let's look also at semi-illiterate smartphone users. So for them to share a variety of location-specific information here, such as price of a commodity, the market name, the quality of the produce, the packaging. Here you see that we adopted a pictographic user interaction compatible with a wider range of age groups and literacy levels. Also, we adopted a semantic data model because, as you know, in Africa, not every market will stay the same at the same location. They may pop up along the road depending on availability of produce or demand. And also even the packaging type in this case, you see packaging types, a remunerated list of literals. Even a bucket is used to buy and weigh produce on the market. So this is an example of building interoperability by design into our data model so that also the smartphone app developer is facilitated in the same process. Sorry there. So here you see the semi-illiterate user design of the UX of a smartphone application with the commodity type in the first step, the marketplace being just a picture of the market you're either selling or buying. The bucket list, as I mentioned earlier, even the value or the monetary value of the produce you buy is just a slide up, slide down to increase or decrease the price that you end up paying. So here you see the semantic software design of, for example, this bucketing or tin or any other packaging type that is being used. And this list is dynamic. It's not based on some preconceived concept of an IT developer. It can actually be crowdsourced. Similarly, we developed this application for post-harvest losses during transport. So profit of the fisherman selling his produce down all the way in some central location in a country, transporting it multiple hundreds of kilometers perhaps. Is the duration of a trip, the road quality, and different weather conditions that affect the microclimate inside the packaging. And so we ran this program with the World Food Programme from United Nations and the European Space Agency to capture these parameters in explaining post-harvest losses. Now, some lessons learned. Here you see the application on the left with an installable link to Google Play. We're using motion sensing on the smartphone to measure the vibrations during transport. And we have an API for that so that you can also measure wave height and other physical conditions using the kinetic sensors in smartphones. And you can clearly see that users are not all the same. And as with all things in nature, things are not linear. So here you see the reporting of road pavement quality using a Edge AI algorithm. We classify these vibrations, saying this is a pothole, this is a rough patch, this is a speed bump, and all those road pavement quality types are then evaluated. And you can see that there are bimodal distributions in this violin box whisker diagram. There are tech-savvy users. For example, in the storm drain former last category on the right, you see there's a majority of users that just uses the app, and there's a much smaller community within your target addressable customer segment that is more tech-savvy, that actually improves the algorithm in detecting these road pavement conditions better. Talking about some examples in the maritime domain, some on smartphone simple analytics. So here we're classifying wind speed for offshore wind park site selection with different parameters. Here wind speed plotted with different parameters being interpreted and classified. And then you end up with a simple traffic light color scheme in red, orange, and green for suitable conditions. So this is also something we tested in the context of invasive species in the proximity of major ports. Mussel farms and oyster farms like these might not only suffer from climate change effects, but also from new species that suddenly are actually non-native and actually dangerous and harmful to the aqua farm activities. And so here we actually engaged some of our Dutch oyster and mussel farmers and also African oyster and mussel farmers
to try and understand how do we interpret this data better, and using their feedback on some of the default value that we brought to the app. So these are examples of views within the app about oxygen temperature conditions from multiple sources. Once we have that critical mass of value that they realize is useful for them, they now start reporting back to us what are their observations, for example, in this case, of a herpes virus outbreak in one of their aqua farming plots. And then also finally, invasive species that they observe using the worms and invasive species marine observation data set. We can then help them in classifying the pictures that they see in addition to labeling of AI images. So in a nutshell, bring critical value, useful data that helps decision makers make decisions in the field where they are so that you can expect something back in return. Build the trust first and then expect more. If you want to build your app in a low-code environment, we have got a Maps API ontology for both iOS, Android developers. So you can now also get code templates so that you can solicit offers in a tender from, instead of 3 companies, you can now ask 5 IT companies or 10 to make you an offer to build a smartphone application, because we've made it really simple to integrate maritime, oceanographic, gridded and other spatial data. So if you want to learn more about how these APIs work, here are all the links to the Edge AI example, classifying wave height from motion sensing data, for example. So the floor is yours for questions.
Thank you, Valentine. Thank you very much for this insightful presentation. Any questions from the room? Okay. Do we have questions online? Okay, so thank you very much, Valentine.
You're welcome. Thank you for
being with us. So here we have ended with the presentation for tomorrow, for today. Thank you very much for having been with us this morning. I will also thank all participants online for having shared with us this time. I think the online part is now over. Thank you very much. I will give the hand to my colleague Anis for the next part of the day.
Thank you, Lie. Thank you very much. I think, yes, it was very, very interesting forum. Thank to all the participants, to all the speakers. It was really very fruitful discussion also. Unfortunately, the online part will be ending now because we are moving now to the field to have a visit to the Al Hoceima MPA through the boat. We'll be moving from the harbor of Al Hoceima to the harbor where there is the Al Hoceima Observatory. And there we will have the last session of the event, which will not, unfortunately, be online, which is related to the poster session. And we will have additional discussion for sure there. And the lunch will be also at the observatory. So with that, thank you all. Thanks to all the participants online also during the 3 days. And with that, we close the online session. But I invite you for the coffee break. It should be short because the boat is at 11. So we only have very few minutes to walk up to the harbor and be there. Many thanks again, and see you soon. Thanks.
Recording stopped.